we go with problem 1, we want to simplify a radical. Now, problem 1 is the square root of 40 that we want to simplify. Now, we know that 6 times 6 is 36, so this guy's about 6 point something. But we don't want to change it to a decimal. We want to simplify it. Just like we take fractions and we simplify them, like 2/4, you simplify to a half. We don't want you to write 2/4 as 0.5. We want it simplified to know what it is in the same form. So to do this, there's a couple ways. There's 2 main ways. Here's the way I like, because I think it helps us later when we get to dealing with some x squareds and y cubes and everything else. If we take 40, every single number can be broken down to a multiplication of a bunch of prime numbers. 40 is no exception. Every single number that exists, no matter how large, I can give you a bunch of prime numbers that multiply together to give you that number, guaranteed. Now, you got to remember what prime numbers are. Prime numbers are numbers that basically can only be divided by 1 and themselves. So that's what we have here. So I got to figure out. Now, you were taught back in probably 5th, 6th grade what's called a factor tree. And I'm going to do a factor tree for this 40. I'm going to think, what multiplies together to give me 40? Well, you have 4 times 10. So I know 4 and 10 multiply. Neither one of those is prime. They still both can be divided. 4 breaks down to 2 times 2. Now this is prime because 2 can't be broken down anymore. The only thing that divides 2 is 2 and 1. So these are prime numbers. 2 is actually your very first prime number. 2 is the first prime. Then there's 3, 5, 7, 11, 13, 17, 19, so forth. Here's 10. 10 can break down to a 2 times 5. Both those are prime. So I know that the prime factorization of 40 is a 2 times 2 times 2 times 5. Those prime numbers multiplied together will give me 40. Now here's the way I like to do it. So I know this is simply a 2 times 2 times 2 times 5. In order to bring somebody out of the house, you got to have a couple. You got to have a pair in order to bring them out of this little square root house. Well, there's a pair. So this pair can be crossed and brought out. Now when you bring it out, they only come out as a single. So a 2 comes out. There's no other pair to be brought out. 2 and times 5, we can go ahead and say, oh, that's 2 root 10. And there we have. Square root of 40 simplified is 2 times the square root of 10, or 2 root 10. Other ways this is taught sometimes, and again, this is my preferred method because you'll never miss a problem. But sometimes it's quicker if you recognize, if we took the square root of 40, sometimes you're taught to look for perfect squares that are in here. By perfect square, what I mean is 2 times 2 is a 4. So 4 is a perfect square. 9 is the next perfect square because 3 times 3. And then you have 16 and 25 and 36 and 49 and 64 and 100 and 400 and all these things. Because if you multiply it by itself, you get that number, which is the perfect square. So I'm looking for the perfect square. The first perfect square we have really is 1. Then you have 4. 3 times 3, 9. 4 times 4, 16, 25, 36, and so forth. Do you notice any of these being able to be multiplied to give me 40? Yeah, 4. You'll notice this is the same as a 4 times 10. 4 is a perfect square, so you can pull out. What is the square root of 4? 2. And you're left, and there's your answer, 2 root 10. But you got to know all these perfect squares, and sometimes it can get tricky if I make a really large number. Prime factorization is always simple. It goes back to sort of 5th, 6th grade math of doing a factor tree, writing them out, finding a pair, and pulling the piece out. Boom. I like this better. Whatever you like, though, is fine by me as long as you know what you're doing. There you have problem number 1. Little long explanation, but hopefully it helped you understand a few concepts in math.